Hi, this is Luke from the Stats Medic, and in this video we're going to talk about binomial distributions. This will be day 1 of 4, and we're going to do that using the activity titled, Is it smart to foul at the end of the game? So we have 2 learning targets to address in this lesson. The first one is to determine whether the conditions for a binomial setting are met, and then the second one is to calculate and interpret probabilities involving binomial distributions. So before we jump right into the activity, there is a short video that you need to see to introduce the context of the activity. So let's check out that video.
And he's trying to go 10 for 10 for the year. Nope. Gotta go in a hurry. 2-point game. Washington. Well, he got hit. Foul on Garcia. He got hit. There's Garcia.
Both behind right there. He's in air. He can cross that line in air. That's not a problem.
Darius Washington will go to the free throw line for 3 shots.
He's shooting 3.
And do the quick math, folks. They're down 2. 73 plus 3 equals a win.
So let's try and summarize all that important information that you saw in the video. It says in the 2005 Conference USA basketball tournament, Memphis trailed Louisville by 2 points. At the buzzer, Memphis's Darius Washington attempted a three-pointer. He missed, but he was fouled and went to the line for 3 free throws. Each made free throw is worth 1 point. Was it smart to foul? So as the announcer said there, if Memphis's Darius Washington is able to make all 3 of these free throws, then Memphis would beat Louisville by a point. So we want to calculate the probability of that actually happening. So you're going to work your way through the activity here. There are a couple of questions. Now we are going to have you pause after question number 2 so that I can start to reveal to you what happens on each one of those 3 shots. So you are going to have a stopping point here. I'd like you to work your way through number 1 and number 2, and then you can come back here to check your answer, and then I'll show you what happens on the first free throw. So go ahead and pause the video now. Let's go ahead and check in on your answers for the first 2 questions in the activity. So for question number 1, we had to figure out all of the possible ways that these 3 shots could actually end up. And there are 8 possible total, which seems reasonable because for the first free throw, there are 2 possible outcomes, make or miss. The second free throw, 2 possible outcomes. The third free throw, 2 possible outcomes. And we just do 2 times 2 times 2 tells us that there should be 8 possible outcomes there. And I've gone ahead and actually listed out all 8 of the possible outcomes. Now for number 2, we are told that Darius Washington is a pretty good free throw shooter, 72% free throw shooter. And we're supposed to use that to find the probability that Memphis will win, lose, or go to overtime. So let's start with the probability that Memphis will win, that first column there, which you see in green. And that's them winning. Now there's only one possible way that they could win, and that's this first possible way with 3 makes. So if he makes all 3 free throws, then we know that Memphis will win the game. So we can calculate that probability pretty easily. Assuming that the free throws are independent, we can just simply multiply the probability of making for each one of the 3 shots. And that's going to give us about a 37% chance that Memphis is going to win the game. Now, I'm going to move over to the third column of overtime right now, because I'd like to think about what would have to happen to get into overtime. And you can see here, I've listed it as 2 makes and 1 miss, which we have represented as the second possible outcome here, a make, and a miss. And so once again, assuming that the free throws are independent of each other, we can just multiply probabilities, make on the first one, make on the second one, miss on the third one, and we end up with a final answer of 0.145. But we are missing a very important fact here. And the fact is that this is not the only possible way that we end up in overtime. If you look at all of our 8 possible outcomes here, you can see that this one would be make, miss, make. They'd also end up in overtime. And miss, make, make, they would also end up in overtime. So there's actually 3 different ways that this can happen. And the probability of each one of these 3 is going to be the same, 0.72, 0.72, 0.28. Now you might move those around a little bit, but when you multiply, you're going to get the same value there. So what we need to do now is we need to go to this answer and recognize that there are 3 different ways that you could arrive in overtime here. Each one of those ways has a probability of 0.145. And so the total here is going to be 0.435. Now I want to pause just for a moment right there and recognize something that we just did here, the calculation that we just made. And I'd like to try and formalize it a little bit by coming up with like an actual formula for calculating this probability. So let's just take a look at what we did here, all right? So we realized there were 3 different ways that we could end up in overtime. And for each one of the ways, we had to have 2 makes and 1 miss. And so the make had a probability of 0.72. We had to have 2 of those. And since we're multiplying, I'm just going to rewrite this as being 0.72 squared. And then we had to have 1 miss, which would be 0.28. And I'm even going to show here very clearly that there was just 1 miss there by raising that to the first power. Now, if we try and turn this into a more general formula, there's something that we need to recognize about this 3 and how we could just mathematically calculate that there's 3 different ways for this to happen. And the way we're going to do that is using combinations. And it turns out that we could just do 3 choose 2 here because there are 3 free throws and we need to choose 2 of them to be makes. And we want to know how many different ways are there of choosing 2 makes out of 3 shots. So 3 choose 2 is going to give you 3, and you can just use your calculator to find that value. Then we're multiplying by the probability of making raised to the second and the probability of missing raised to the first. Now, I'd like to try and write this as a more general formula here. So here's what the formula looks like in general. It is n choose k, where n represents the total number of shots. For us, we had 3. K represents the number of makes. For us, we needed to make 2 of those. Then this 0.72, I'm going to write as p, and that's going to be raised to the k power because we have k makes. So p is the percent of a make or a success. And then we need the percent of missing. Here is 0.28. In the formula, I'm going to write it as 1 minus p. That is the percent chance of missing. And then we have to know how many misses there are. Well, if there are k makes out of n total shots, then there are n minus k that are going to be misses there. And so this formula that we've written here is called the binomial formula, and it allows us to calculate the probability of exactly k makes out of n shots. Now, we still have this middle category to take care of here, which is losing. And so for losing, there's a couple of different ways that that could happen. One, we could have 3 misses. That's this possibility right here. But then the other way that we could also lose is 1 make and 2 misses. So 1 make and 2 misses. But once again, that's not the only way of getting 1 make and 2 misses. We've also got this possibility here and this possibility here. So we need to make a little bit of a correction here. There are 3 ways of getting 1 make and 2 misses. And when we multiply by 3, we're going to get a value of 0.169. And now to get our final answer for the probability of losing, we know it could happen by getting 3 misses or 1 make and 2 misses. That's an or probability, which means we will have to add those 2 together. And when we add those 2 values together, we're going to get a final answer of 0.191. Now, if we look at question number 3, it says prior to watching each shot, calculate the probability that Memphis wins the game in regulation, loses the game in regulation, or sends the game into overtime. And we've actually just figured out those first 3 probabilities. The probability that Memphis wins is right here. We can carry that down, 0.373. The probability that Memphis loses, we said the total is 0.191. And the probability of overtime is 0.435. But let's go ahead and check in and see what happened on the first free throw.
For the season, 72%. If he hits 3 in a row, Memphis goes to the NCAA championship. 2 to go.
Boy, does that take the pressure off right now.
So we saw in the video that Memphis made the first free throw. So now we have a new score that we need to record here. The score is now 75 to 74. They're only down by 1 point with 2 shots remaining. And now we're going to have to recalculate our probabilities. So now that we know that Memphis made the first shot, let's calculate the probability that Memphis wins here. Well, in order for Memphis to win, they now need to make and then make. The final 2 free throws has to make them both. We can calculate that probability pretty easily. 0.72 is the probability of a make. There are 2 of them, so we have to multiply it by itself or square it. And we're going to get an answer of 0.5184. About a 52% chance now that Memphis is going to win. For Memphis to lose now, they would have to miss both of the final 2 free throws. So we can calculate that probability as 0.28 squared, and that's going to give us 0.0789. So about an 8% chance now that Memphis will lose. And then the probability of overtime, well, let's think here. In order to end up in overtime, could be a make-miss, or it could be a miss and then a make. 2 different possible ways that we're going to end up in overtime here. So the make and then a miss would be 0.72 times 0.28. The other possibility of miss and then make is just the same thing, but sort of in the reverse order, which would still give us the same answer. So I really just need to double that answer. And that's going to give us 0.4032. So there's about a 40% chance now that Memphis will end up in overtime. So now that we know this, let's go ahead and check out what happens in the second free throw. So we saw in the video that Memphis missed the second free throw, and so the score remains the same at 75 to 74, with now 1 shot remaining. So now that we know there's just 1 shot remaining, the probability that Memphis will win here, well, now they can't win, right? Even if he makes the last free throw, they're still just going to end up at a tie. And so the probability that Memphis wins is 0. The probability that Memphis loses, well, if he misses this last free throw, Memphis is going to lose the game. And so the probability that he'll miss is 28%. And then the probability that we end up in overtime, well, if he makes that last free throw, we're going to end up in overtime, and we know there's about a 72% chance of that happening. So let's check out what happens on the last free throw.
Vern, I will be hard-pressed to tell you right now that if you'll see a more pressurized situation this year.
Tournament's on the line. Louisville wins.
Somebody's got to go help that kid out.
And the first man there is John Calipari.
So that is just so painful to watch. I've seen this video dozens of times, and it's still just hard to watch that last free throw bounce out. All right, well, we have 1 last remaining question here in the activity, and I'd like you to try this one on your own. Think about it and come up with some sort of a decision on number 4, and then you can come back here to check in on your answer. So go ahead and pause the video now. In question number 4, we're given some additional information that Darius Washington is a 40% 3-point shooter. Do you think Louisville was smart to foul? Why or why not? And so the solution I have here says, yes, it was smart for Louisville to foul. And here's the reasoning. Suppose that Louisville doesn't foul and they just let him shoot the 3-pointer. Well, if he shoots the three-pointer and he makes it, then Memphis wins. And so because he has a 40% chance of making the three-pointer, Memphis has a 40% chance of winning. Now, if Louisville fouls, we just went through here and calculated the probability that Memphis will win as 37.3%, which is lower than 40%. So it seems at first glance that for Louisville, the coach should tell his players to foul because it will decrease the chances that Memphis wins the game. But there's something that's missing in this analysis. That 37.3% chance of winning is the chance of winning in regulation. There is still the possibility with the free throws that they do end up in overtime. And Memphis surely could win in overtime. And so it's not crystal clear whether or not Louisville should foul here or not. So let's see if we can summarize our learning in the important ideas. For the important ideas, let's go back to the learning targets from the beginning of the lesson. The first learning target was about the conditions for a binomial setting. So let's label this as LT number 1. And this is going to be the conditions for the binomial setting. So in the activity, 3 shots, let's suppose that X is the random variable which represents the number of makes. And so X would be considered a binomial random variable because it satisfies the 4 conditions necessary for a binomial setting. So the way that we're going to remember the 4 conditions is using the acronym BINS, BINS. And let me tell you what each one of those conditions looks like. For B, that stands for binary. And that means that each trial is either a success or a failure. In the 3 shots example, very easy there. There are, for each one of the shots, a success would be a make and a failure would be a miss. I stands for independent. And the idea here is that each trial is independent of the next. And we had to assume in the 3 shots activity that each free throw was independent of the next free throw. And then N says that the number of trials is fixed. And for us, the number of trials we know is fixed. It was 3 shots. So we would use lowercase n to represent the number of trials, and for us it was n equals 3. And then the last condition S says that there is the same probability of success for each trial. And in the context of the 3 shots, the probability of success was the probability of him making the free throw, which we know was 0.72. And so we would say lowercase p, the probability of success, was 0.72 for each trial. So if all 4 of those conditions are satisfied, then we can say that that random variable is a binomial random variable. Now, the second learning target had to do with calculating probabilities. Which we did in the activity, and we actually ended up with a formula for that. So let's just list this as learning target number 2, and this is what's called the binomial formula. And so here's what the binomial formula looks like. If we are trying to find the probability that our random variable x is equal to some number k, like for us, maybe we want to find the probability of exactly 2 free throws made. We came up with a formula that said n choose k times the probability of success raised to the number of successes times the probability of failure raised to the number of failures, which is n minus k. And let's clearly specify what each one of these variables represents in this formula. Okay, the n right there is the total number of trials. For us, it was 3. The k represents the number of successes. The p right here is the probability of a success, which means 1 minus p is the probability of failure. And then for those exponents there, k is the number of successes. And then n minus k is the number of failures. So we can use that binomial formula to calculate the probability of a certain number of successes in a fixed number of trials. So let's see if you can apply your learning from the activity in the Check Your Understanding problem. There are 2 questions, each with 2 parts. So go ahead and try that on your own and then come back here to check your answers. So you can pause the video now. Let's see how you did on the Check Your Understanding problem. So for each one of these, we first had to decide whether or not we have a binomial distribution. In 1A there, we're playing the game of whack-a-mole, and we're gonna play the game 20 times, and we have an 80% chance of hitting each one of those moles. And so in order to justify why this is in fact binomial, you do have to make sure that you address all 4 of the conditions. So make sure in the binary condition that you're clearly identifying what is a success and what is a failure for each one of the trials. For independent, they actually gave that to us in the problem by telling us that each trial was not affected by the previous one. Where the number of trials is fixed, make sure that you indicate what is the total number of trials here, which is 20. And then for the same probability of success, make sure that you indicate the probability of success for each one of those trials. Now for part B, playing skee ball, you have to be careful to notice the way that the random variable y is defined here. It is the number of balls you must roll until you get one in the 10,000 point hole. Now we don't know whether that's going to happen on the first roll or the 3rd roll or the 10th roll or the 100th roll. So one of our conditions for a binomial distribution is not satisfied here, and that is the number of trials being fixed, because we don't know how many trials it will take. And so it turns out that this variable y is not a binomial random variable. It's what's called a geometric random variable, which you will learn about in a later lesson. Now for number 2, same thing for part A. We had to go through our 4 conditions there, making sure we defined a success and a failure, making sure we identified the number of trials as well as the probability of success. And then the last question, we had to find a probability of getting exactly 3 successes out of 10 trials here. And so this is where we're going to use the binomial formula. So here 10 is the total number of trials. 3 is the number of successes that we're looking for. The probability of success for each trial raised to the number of successes. The probability of failure for each trial raised to the number of failures. And that's going to give us about 0.2013. This concludes the video for binomial distributions day 1. Thanks for watching.